Good afternoon. How are you?
Well, thanks, sir.
I'm also good. I think you are all here. So we can start with our lesson just now. All right. Before we start with the topic of today, I would like to find out from you. Which topics have you covered from school this previous week? Which topics did you cover from school this previous week?
Sir, can we please go back to those, I don't even know what to call them, but wherein we were multiplying the I'll just send them to you.
All right.
We are going to write about them as a test, and I still don't think I understand them.
Oh, you're going to write it. You're going to, yeah?
We're going to write test.
When are you going to write a test?
It's either Thursday or Tuesday, I'm not sure.
Tuesday.
And what's the scope of the test?
He said that everything that we've been doing.
All right.
Adi,
Hmm?
do you still have that test paper that we wrote, that monthly test paper, or should I send it to you?
That one won't be part of it because we wrote it as an assignment and then we wrote it as that other test.
All right. Send me the questions that you feel we can attend to in our lesson today.
Maramba.
All right. I'm opening the solutions you sent to me just now.
Some of them we have already done them.
Yeah, exactly. Okay, it's questions on exponents, man.
Mm.
All right, that's okay. So we can skip those I've done already, and we focus on the ones I did not do. All right, let me also find out from Mukundi. Mukundi, are you going to write any test soon from school? Mukundi, are you going to write tests from school anytime soon? Okay, it seems as she left because of
He
network.
left.
All right, no, it's okay. Let's do these questions that we have here for simplifying. So I'll take you through each and every question that we did not do the previous time. But before then, I would like to remind you about the exponential rules, which you must know in order to answer any of these questions that are sent to me. So you need to understand the rules. So those are called the exponential rules. You need to understand the exponential rules. So I'm not going to give you all the rules because they are many. We're going to just do the rules that are to be implemented on these questions that we have here. So the very first rule that you must understand is when we are given two bases which are the same. You can see the base on this first expression is A, and the base on the second expression is A. So the bases are the same in this case. But the index or the exponents is what is different. So now, if bases are the same, there is a rule which is called exponential rule, which say that if bases are the same, we add the exponents. So in this case, it means we're going to have A to the power of m plus n. That's the first rule which you must know that will assist you to answer the questions we're given here. Whenever we are having the same basis, we can add the exponents and then we have a new expression that is given this. And now let's go to the second rule that you must know, which is very important. It's when an expression is now having two exponents. So the base A is having an exponent of m and is also having an exponent of m. So to attend to these kind of expressions, we have to multiply, as according to the exponential rule, we have to multiply the two given exponents. So if we multiply the two given exponents, we're going to have A to the power of m multiplied by n. So that is the second rule, which you must know. And the third rule is when we are having a fraction, let's say we have A to the power of m divided by A to the power of n. If bases are the same and you have a fraction, then we have to subtract. We have to subtract the index on the numerator and the index on the denominator. And then the last rule, second last rule, which I want to introduce you to, is when we are having an exponent of 0. Now I want you to tell me the answer of that one. What is any number to the power of 0?
1.
1.
It's 1. You must not forget that. It's easy, but it's very important. A to the power of 0, it must be equal to 1. Or in other words, this is simply to say any number to the power of 0 is 1, regardless of the fact that the number is too big or is too small. Whenever it's any number, then if it is having an exponent of 0, it must be equal to 1. And then number E, it's when we have A to the negative 1. A to the negative 1. You can write this as 1 over A. So these are the 5 rules which I gave you now purposefully because we're going to apply them in the questions you gave me just now. The other one is the reciprocal rule. I will explain that reciprocal rule when we do questions. But in the meantime, you must understand these 5 rules which I gave you here. Can we start with questions just now?
Yes.
All right, wonderful.
Yes.
Let's do the questions. So you might remind me if I'm repeating the questions we have done the last time. So I'm now starting with questions on exercise 5.3, question number 2E. I choose question 2E because it's the only one that is not cycled. I think we have done these ones which are cycled already. So let me do question number 2E, given as 3 to the power 3a to the power of 5b to the power of -4, all divided by c to the power -7, and then to the power of 2.
We've done that.
We have done this question.
Yes.
Tell me the one we did not do then. Is there a question we did not do on exercise 5.3, question 2, from A to E? Which one we did not do on those ones?
From number 2, we have done all of them.
We have done all these questions. All right. So it means we can go to other questions on. She sent me these other questions on. I don't see the page there, but these ones I'm sure we did not do even a single question from those ones. So let's pick the questions from this page. So we will start with.
It's on page 73.
Is page 73, eh? All right. No. So we're gonna start with question number 1Q, which is given as 4 divided by 3 to the power of -1 x to the power of 2 is x to the power of 5. We are required to simplify that expression. 4 divided by 3 to the power of -1 multiplied by x to the power of 5. I can tell you without any hesitation that we are going to use one of these rules that we have here, including the reciprocal rule, of which I will explain the reciprocal rule by using the example that we have. So I'm going to explain a reciprocal rule from this question that we have there. Can you see these questions that I wrote on the board?
No. The phone is.
All right, let me write it down here. I hope you can see the question now.
Yes.
All right, wonderful. So let's do this question together. Whenever you see an exponent of negative, it's only one rule that must come into your mind. Rule number A. A to the power of -1 is equal to 1 over n. So it's the same rule that you have to apply here. So 3 to the power of -1, we are going to write it as 1 over A. Are we all together?
Yes.
Yes, that is the step we're supposed to do just now, wherein 3 to the power of -1, we are now going to write it as 1 over 3 multiplied it by x to the power of 5. The only thing we did here is to replace 3 to the power of -1 by 1 over 5. And then after having that, we can then multiply this x to the power of 5 with 1. You don't multiply this with 1 and then multiply with the denominator. No, you only multiply it with the numerators, because if this is in terms of fraction, so it means we're going to multiply 1 with x to the power 5, and then we multiply this 3 with the denominator that we have there, of which is 1. So then now we're going to have 4 divided by 1 times x to the power of 5. It will give us x to the power of 5 divided by 4. Do you see we now have an expression in terms of 2 fractions? Do you all see that?
Yeah.
In that situation, whenever you come across this situation, wherein the expression you are given is in terms of 3 fractions or is in terms of 4 fractions, the only rule that applies in that case is the rule number F, reciprocal theorem. That's the rule that works in this case. We have to use the reciprocal theorem. So I'm going to explain this rule because I know it's the most difficult rule from all the 6 rules that we have on the board. So I'm going to explain it thoroughly so that you don't forget it even a single day. So now, the big division here, because we have a small division and a big division. So the big division that we have there, we are going to change it to be in terms of the multiplication. So now instead of writing division, we now change and multiply the what? And write the multiplication. So, but now, when you change division to be in terms of multiplication, these values we have here, they're going to swap the position. The numerator changes to be the denominator, and the denominator changes to be the numerator. Are we all together?
Yes.
Whenever we change division to be in terms of multiplication, numerator changes to be the denominator, and the denominator changes to be the numerator. So now tell me, if you understood what I explained just now, tell me what is going to be a new fraction if we apply the reciprocal rule. We're going to multiply by what? Yeah.
3 over x to the power of 5.
3 to the power of 3 over x to the power of 5. That is very true. And now, because you're multiplying with a fraction there, even that 4, you can write it in terms of fraction by dividing by 1. Of which from there you can multiply 4 and 3, which will give you a 12 divided by, and then you multiply 1 with x to the 5, it will give you x to the power of what? X to the power of 5. Do you all see that?
Yes.
That is how you deal with these questions. It's the very first question I've done on the board. I'm gonna do 2 questions, first 2 questions, and this is the first one. I'm gonna do the second one. The third one, you're gonna try it by yourself, so that I see if indeed you understand what you are doing. Let me wrap here and do the second question for you. The second question that I'm gonna do is question number, I want to choose a difficult one. All right, I'm skipping question number R and the S because they are simple. And do number T because it's difficult. So we have m to the power of 9 divided by n to the power of negative k to the power of 4. I believe you can see that a question I wrote on the board, né? So now let's do this question together. Again, we have to apply exponential rules to deal with these questions. N to the power of negative 2, we must change it to be in terms of positive fraction. So we are going to write this as m to the power of n divided by. If you understood what we have done on the previous question, how are we going to write n to the power of negative 2?
1 over n to the power 2.
We are going to write this as 1 over n to the power of 2 multiplied by k to the power of 4. Are we all together?
Yes.
All right. And then from there, we have m to the power of 9 divided by the 1. It must multiply with k to the 4. So we're going to get k to the power of 4 divided by n to the power of 2. Now tell me, from there, what are we going to use to deal with that kind of question?
The reciprocal
Theorem.
Theorem. We're going to use the reciprocal theorem to deal with this question. And tell me, if we apply a reciprocal theorem here, what are we going to do with the division?
Change to multiplication.
We change division to multiplication, right?
Yes.
And when we change division to multiplication, something happened on this fraction on the denominator. What is going to happen on the fraction on the denominator?
The denominator becomes the numerator.
As simple as that. Yes, very true. And then tell me the new expression that we're going to have.
M to the
2
power
to the
n to
power
the power
n.
2.
Yes, exactly. It's n to the power of 2 divided by k to the power of 4. But now, because we are multiplying a fraction, we can also write m to the power of n in terms of fraction by dividing by 1. You did not violate any rule by doing that. Are we all together?
Yes.
Yes.
All right. Then from there, we multiply this with that. We're going to obtain m to the power of 9, n to the power of 2, all divided by k to the power of 4. And that is the final answer we were looking for. Did you all understand the two questions I've done on the board?
Yes.
Mm.
All right. Can I give you a question to try?
Yes.
All right. Wonderful. So I'm grabbing this question here and here the question you can try. I will want you to try question number V, which is given as a to the power of -6 divided by b to the power of -4. That is the question for you to try, and I will want you to do that question in the next 3 minutes. When you are done, you can send it to me on WhatsApp.
Sir,
Hello?
you must also do the one Rufna sent on page 75.
Oh, okay. Let me check. I don't have questions on page 75. Can you please send the questions to me? 5 minutes has elapsed. Are you done?
Yes.
All right. Can I do a correction for that question on the board? Let's do correction for the question together. We have a to the power -6 divided by b to the power -4. So again, on this question, we are applying the rule for negative exponents, of which a to the power -6, we can write it as 1 over
Over 8 to the power 6.
So that is the small division.
Yes.
The bigger division is this one, of which you have to write it as big as it can be visible to everyone. So this is a small division, that is a big division. And from there, we do the same with b to the -4, of which you can write b to the -4 as 1 over b
Over b to the 4.
to the +4. Are we all together?
Yes.
Is this a big division or a small division?
A big division.
Big division.
It's a big, no, it's a small that one.
This one is a small division, and that is a big division. So you must be able to differentiate the two, because that knowledge we're going to apply it when we use the reciprocal theorem. Are we together?
Yes.
All right. So the big division is the one we change to be in terms of multiplication. Is that okay?
Yes.
Yes, we're going to change this division to be in terms of multiplication. So the smaller division, we leave it as it is. Like here, we're going to have 1 over 8 to the power of 6. But now, this big division, we change it to be in terms of multiplication. And I know by now you can tell me what happens on the denominator whenever you change the division to be in terms of multiplication. What's going to happen if we change the division to be in terms of multiplication?
The denominator is going to become the numerator, and the numerator becomes the denominator.
Very true. And in this case, what are we going to have?
B to the power 4 over 8 to the power 6.
Wonderful. So we have b to the power of 4 divided by 1 is this one we have here. And then from there, you are only left with multiplication of numerator with numerator, denominator with denominator. And in this case, we're going to have 1 multiplied by b to the 4, which gives us b to the power of 4.
4.
A to the power of 6 multiplied by 1 gives us a to the power.
8 to the power 6.
Is that okay?
Yes.
Yes.
Yeah, exactly. That's how you attend to these kind of questions. Now tell me, are we supposed to divert to the questions I received just now, or we continue and finish with these questions? And then tomorrow we focus on the questions on exercise 5.4. What do we do?
Let's finish with this ones first.
Yeah, let's finish with these ones. All right, that's okay. That was question number V. And now I'm gonna give you another question, because I did not know who was able to get this right. So the next question, I would like to find out if you are able to get this right. So I'm giving you question number W, which is given as x to the power of -4 divided by y to the power of -7, z to the power of -2. That is the question which I want you to try in 3 minutes time. And when you are done, let me know so that I find out if you are doing it correctly. You can send to me the question so that I advise you of how you're supposed to attend to it. So now it's your time to do these questions. I'm giving you 3 minutes to attend to that question.
So I'm done.
All right, you can send the solution on WhatsApp. I'm only left to receive a solution for Rufuno. Rufuno, you can send me the solution you obtained before we do a correction. All right, wonderful. So let's do correction together for that question. So you're gonna compare the answer you obtained with the answer that I'm going to get on the board. So now you can see all these variables, they have negatives. So it means we must apply that rule for changing the negative to be in terms of positive exponent. So x to the power -4. How can we write x to the -4 in terms of positive exponent?
1 to the power 1 over x to the power 4.
Yes, very true. And that is a small fraction that we formed there. So this is a big fraction which you must take note of at all times. That's why you're going to use it for the reciprocal theorem. Now here we have y to the -7. How are we gonna write y to the -7?
1 over y to the power 7.
1 over y to the 7. And then for z, how are we gonna write the z there?
1 over z
X
to the
over
power 2.
to the power 2.
Yes, very true. And they are multiplying to each other. All right. Then from there, we have 1 over x to the 4 divided by, this is the big division. So before you do the simplification, you need to multiply these two fractions first because they are on the same denominator. So you can multiply 1 with 1, you obtain a 1. Divided by, you multiply y to the 7 with z to the 2. Y to the 7 multiplied by z to the 2. Are we all together?
Yes.
Did you all see how we arrived to this expression?
Yes.
All right. Wonderful. From there, we change this big division to be in terms of multiplication. So when we change big division to be in terms of multiplication, I believe by now you know what is going to happen on the denominator. So we're going to have
Yes.
1
1
over
over
x
x
to the 4. What do we do with the division? We multiply, right?
Yes.
Mm.
And then the denominator,
Y to the power 7, z to the power 2 over 1.
very true. That is what you're going to have. And then it's now safe to multiply numerator with numerator, denominator with denominator. So if we multiply this one with